What's crapping? Stop yapping. I'm building some shit. I am Cordell Rufus III. I'm going to do an unboxing for you guys. This is the Aeromotive 5.0 gear drive brushless pump with the, it should be the Signature series with the feet, and it also has a 5-volt speed input. So, and I'll show you guys that as we go. I'll also walk you through kind of how I wired it in the car, which you can wire the same way on any car really if you don't have the ability to put out a 5-volt speed source, and you generally don't want to tap into your 0 to 5-volt output on your TPS sensor, because your TPS sensor is kind of it's a sensitive, you know, it's voltage sensitive. I mean, it's 0 to 5 volts, so anytime you have something else drawing off of it, it's gonna mess up the kind of voltage you're getting through. So we got looks like a banner or something, and we will take a look at this pump. I got this direct from Aeromotive. The pump runs about $1,300, $1,400 or so. This is the 11196 fuel pump 5.0. I think they call it a spur gear style brushless pump. But this will flow about 1,800 horsepower worth of fuel on ethanol. So we got a couple stickers, and then we got some directions, which we probably won't use. But basically all you get in the box is the pump. So if you're planning on having fittings or anything, you need to get those. You're going to have a -10 ORB or O-ring output and a -12 ORB O-ringed input on the other end, and your wiring comes out of the output end. So what you have here is you have your red and your black, which are power and ground, obviously. So when you get the 12 volts signal straight from your normal fuel pump wiring, you're going to want to run a 40 amp relay regardless with this. So in my case in the car, my stock fuel pump wiring is just tripping a 40 amp relay, and then that will power on this pump. So when you have 12 volts to the red and the black's grounded out, this pump will run at 30%. So at 30%, you're running at about just under 400 LPH. So I believe that's what it kind of equates to. It's about a little like around 1.5 gallons of flow. So then you have this yellow wire. So this yellow wire, you can run a 0 to 5 volt input. So I believe anything over 3.7 volts is going to be 100% on the pump. So if you're just going to run the pump at 100%, you can actually just connect the red and the orange, or the red and the yellow, and just send 12 volts to both, and it'll run high. Or you can just run a secondary if you want the pump to just kick on 100%. At a certain RPM, you can do something like what I'm doing, where I'm running a Hobbs switch that goes to 12 volts, and then it'll just feed 12 to this. So just be aware that you can put 12 to 16 volts to the signal wire for speed control, but it's only going to run the pump at 100%. So if you want to run the pump less than 100%, which I think we're going to try to do on my car because I don't think I need that much fuel up top, you're going to want to have some way to regulate the output voltage. So on my car, I'll kind of walk you through once we get in there what it is, but essentially I'm going to have twin -10s coming into the -12 end to feed the pump from the tank. And then you have a -10 coming out, which feeds a Y that goes to twin -8s that go up to the fuel rails. And then I have a -6 return, which is one of the reasons why I don't want to run the pump at 100%. I want to make sure that my -6 return isn't going to be putting so much restriction in the fuel system that I won't be able to regulate the fuel pressure properly. So I know that before, when I was running twin 400 LPH AEM pumps, it was fine for having a single -6 return, but this will flow a lot more than that. So we will see how that works out. Basically what I'm going to end up doing is adjusting the voltage on my speed control output until I get the pump down enough to where the regulator can regulate it at full RPM. So we will see how it all works out, but I'll get this hooked up and then I will walk you guys through how I have it all set up and how I have the wiring set up for this guy, so you guys can wire up a brushless pump and still be able to use the variable speed if you want. Even if you don't have an ECU that supports it, you can run a full standalone separate system. So it's pretty cool. I'll switch you guys over in a second. Okay guys, I'm going to show you guys how I have this Aeromotive brushless pump wired up on my E36. So as you know, the brushless pumps use 0 to 5 volt output. So a lot of the ECUs don't allow you to do an output like that. And what's cool about the Aeromotive brushless pump is it has a controller built into the pump, where normally you would need a pulsed output to vary the speed of a brushless pump. So what I have is kind of a foolproof, not really foolproof, but a really basic way of handling the variable speed pump setup in my E36 with the Haltech. And you can actually use it with the Haltech if you want also. So what we have here is this relay is triggering on and off with my normal fuel pump wiring. And this is a 40 amp relay that is going to the 12 volt side of the brushless pump. And then the ground, obviously on the brushless pump, is going to ground. So when my key turns on, where normally my fuel pump would turn on, it's sending 12 volts to the brushless pump, which on an Aeromotive brushless pump runs it up to 30%. Then we have a hob switch right here, and that has a vacuum line that runs up to the intake manifold or vacuum block. And that is adjustable. So I have that set around 20 psi. So at 20 psi, which we can simulate here just by jumping the hob switch, at 20 psi, it triggers this relay, which used to run a second pump that I had because I had a 2-pump system. So this other relay that's running off the hob switch is actually powering up a voltage converter, and this voltage converter is converting my output voltage to 4.84 volts or whatever volts I want it to output to. So I can turn that down to 4, 3, 2, 1, or any variation in between. So when my hob switch kicks on at 20 psi, I can simply spin up the pump for as fast as I need it to spin up, which for my setup, I don't think I need it to run at 100%, so I can drop that down. Any voltage below 3.7 will drop the pump down a certain amount. So as long as if I have that adjusted, then I'm not going to overwhelm my return, because obviously the engine is demanding fuel at the same time. So that's how the wiring is set up for this. So what's cool about this setup is if I want that secondary switch to not run off a hob switch, I can run a DPO or digital pulse output off of the Haltech that's set up for nitrous, and I can run that to the low side of that relay, and then I can trigger the second speed of that brushless pump off of the Haltech. So I can adjust any load characteristics in a load table where 20 psi, 15 psi over 80% TPS or whatever you want to do. And you can have it triggering on the pump to kick it up to a higher speed. So 30% of that pump will run about 380 liters per hour, I think, or somewhere around there. A little less than 400. So about the same as a single one of my old pumps. So on my old pumps, I had my secondary pump kicking on at 20 psi. So I know that under 20 psi, that pump running at 30% will still work fine. So now I'm going to take you under the car so you can see my plumbing. But my camera light took a dump, so we're going to use a flashlight that I have over here, and I will show you how I have this all set up. So underneath the car, kind of hard to see, but we have twin -8 lines going into a Y, and that's going into each side of the fuel rail. That's getting wide. We're kind of working backwards towards the pump, goes wide into a dash 10 that goes into a dash 10 through 10 micron micro glass Aeromotive filter, and that 10 line goes all the way back to the gigantic pump. So we have our pump now, which is right here. So this is the Aeromotive brushless pump mounted. I put 4 nut certs in the chassis to mount it, and then we have our wiring going in, and then feeding the dash 12 is twin dash 10s. So that's a 2 dash 10s going into a Y, feeding the dash 12 inlet on the Aeromotive pump. And that's because when I had my twin 400 LPH pumps down here, I had a single dash 10 going from the tank into each ones. So now I have both of those dash 10s that used to feed 2 pumps. Now they're feeding a Y that goes to a single dash 12, which should be about the same capacity. And that is in turn feeding this huge pump. So I didn't have to change a lot of the plumbing, but I was able to add dash 8 lines. So what I'm running up front now is I have a dash 8 coming in on the end of the fuel rail here, and then a dash 8 coming in the end of the fuel rail here, and then I have a single dash 6 in the center of the fuel rail going over to a single in, single out Aeromotive fuel pressure regulator, and that seems to be doing fine. Even with the car just idling, and if you crank the pump up to 100%, which I just had my son help me do, he jumped the hob switch to turn the speed of the pump up, and it was still hovering a little over 45, so obviously it's pushing a lot more fuel through the regulator than it should be at idle, but we're only going to be running 100% at 20 psi, which would bump our fuel pressure up to 65 pounds because we are running 45 pound base pressure. So if you're running, the big thing with running the brushless pumps is that, number one, you can push volume. So that's why we upgraded. I was running twin dash 6 feeds and a single dash 6 return. We switched to twin dash 8 feeds and a single dash 6 return. So I didn't change anything on the return side. And so far it seems to be working okay. Motion Raceworks actually makes a really cool bypass dash 10. So you can run a dash 10 return and still use a dash 6 in and out flex fuel sensor, because flex fuel sensors, they don't make big ones. So what it does is it bypasses part of the flex fuel, so it kind of runs around it, kind of like a river around a rock, so to speak. So if you want, so far the dash 6 has been okay, so we shouldn't have to mess with that too much. But what's cool is now I can run the Haltech engine protection on fuel pressure, because before, if you're running as map pressure as your reference on your Haltech and you're only running twin 400s, a lot of times your fuel injectors my fuel injectors are 2000 cc injectors. So at top end RPM, even at 45 pounds of boost, which would normally be running 90 pounds of fuel pressure, because it'd be 45 psi on top of 45 base. It was still running fine because my fuel injectors are so big. But even though the fuel pressure was really only getting up to about 80 psi or about 78. So with a 15-pound deficit in pressure of fuel, the Haltech was kicking on the engine protection, thinking it's saving the engine. So now that I have the brushless pump in there, not only is it only a single point failure for your fuel system, which is awesome for running engine protection anyway, you're actually able to run the proper fuel pressure, so you can set kind of the tolerance that the Haltech looks for between your manifold pressure and your base fuel pressure. So you can't go any farther than I think 14 psi or 15 psi anyway. So now we can set it to like say 10 psi or something, which would give it a little bit of time for the regulator to catch up, and then we can run the engine protection, and then hopefully we can set severity at like 3 and just have it straight shut the car down if it gets low fuel pressure, which on a system like this is a lifesaver, because you know if you have low fuel pressure up top, something isn't working, whether it's the hob switch didn't kick on, the pump's taking a shit, something's wrong. So hopefully what's cool is we'll be able to use those engine protections, which is really, really cool. So hopefully you guys got something out of that video. If you have any questions, feel free to ask them in the comments. But so far,
The engine, everything's working really, really well. We actually had the cylinder head refreshed for no good reason at all. So that's a whole nother story. I think it's David at Head Games was super, super cool. So we ended up sending the head out to have him refresh it, even though what didn't end up being the cylinder head, it ended up being something totally fucking stupid. And I don't even really want to talk about it, to be honest. But I'll send a video out for that. But we should be able to run, now with the 8685 precision ball bearing turbo, we should be able to run and hold 50 pounds of boost. So before we were peaking 45 and holding about 40, 42. So we should be somewhere around 1250, 1300 range wheel when we get this guy all up and running. So hopefully it all works out. Pretty cool. Yeah.